New week, new episode of Learn Software Architecture. Last week I continued our series on evolutionary architecture where I showed you the first step of it. The step was called simplicity. We were focusing on building simple apps. Today I would like to continue with chapter 2 where we want to focus on maintainability. It's quite common that your application will evolve. At some point it might grow to a level where you need to start thinking about different approach to keep it still robust and maintainable. Imagine that your application is now used by 5,000 users and their activity in the application is quite high. It reaches our MVP assumptions. So before building an app, we are thinking that okay, at 5,000 we should be able to say that our application was successful. A lot of new features are added to our solution. It changes daily. We are observing users, we are surveying them, talking with them about their feedback, what do they need in our application, and we are adding more and more. Part of the application changes really often. We talk here about several times per day. The contracts module is becoming increasingly complex because of new business logic that is added to it. We have several development teams that start to complain that they are touching the same areas as other teams, and it is very hard to commit to our code to have the latest changes. It is this time where we want to split our single production code project to multiple ones and wrap them into some boundaries. And I remind you that we set up all the boundaries already in the beginning, but they were represented by folders, namespaces. And here we are just taking this code that was in these folders and we are extracting it to set of the projects. One very important thing here is that each area will be represented by different set of projects, because it makes no sense always to just put all the layers that you can imagine, like API, infrastructure, core, and application. Sometimes it just makes sense to have API, and sometimes it makes to have API in combination with some data access project and so on. Before even touching our code, it is a great idea to focus again on our deployment strategy. If you remember first episode, I mentioned there that whenever you are starting building your new application, it usually makes no sense to start with microservices, because in majority of cases modular monolith will be enough. And this is how we tackled it in first chapter. We divided our modules into folders that were representing them, and if you can remember, these folders were passes, reports, contracts, and offers. At that point in time, we need to take our current state, as mentioned in the beginning. We have 5,000 users, frequently changed module of contracts, teams which are complaining about problems with committing and merging code, and so on, that it might make already sense to just grab microservice out of this modular monolith, for example, for this contracts module, take it out and implement it as a separate deployment unit. But still, if you ask me, for such numbers that we have, probably it makes way more sense that we somehow modularize our application code. Additionally, that we scale our modular monolith as entire unit. So we have replicas of our modular monolith. And how it can look like from the architecture perspective. This picture represents the current state of our infrastructure. We have two blocks, modular monolith and database. How they are represented is up to you. In first chapter, I mentioned that you can have a virtual machine per each, or you might have app service for your application and maybe some service for your database, or your database can be hosted somewhere else, and so on and so on. So this is the moment where we need to start thinking about other blocks, because we are starting to have problems with read operations. What to do when you start having problems with your read operations is that you can just grab a read replica that is located besides your master database, and from this point in time, this read replica can be used for read operations. So whenever we are writing something to our database, it gets replicated into this read replica. It will take additional time, of course, but now you have at least two instances that can handle your read operations. What is important to know here is that you can as well take and put another read replica and another and another and another. Therefore, you will have a lot of databases that will be able to answer your request, the request from the user for some data. And of course, we are talking here about read operations. However, at some point you might have so many replicas that it might make sense to introduce cache to your application. And this is a separate block, separate component. You might know, for example, Redis cache, which can handle a lot of requests per second. This is this moment where we should stop for a second, because you probably see that instead of two components that we had before, we might have at the moment 20 different components, because we have our modular monolith, which is represented by one block, and then we might have 18 replicas for reading, one write database, and additionally this cache. It gets more and more complicated. So you need to remember that always when you add new component, the complexity of your solution will grow. It's a natural process and you can't do anything with that. And that's worth to remember, that it's wise to always think if I really need this component or not. From the database perspective, we are fine. Now we need to start thinking about our block, which represents the web application. What happens here is that we need as well to scale it. This is the main problem on our diagram right now. And to scale it, we need to take entire deployment unit, in our case it is our modular monolith, and replicate it to several different instances. The more instances we have, the higher costs we will have, of course, and it will take as well time to just take entire modular monolith and scale it to multiple instances. There is another problem, that we need somehow to push our traffic that is coming, so all the requests that are coming from the outside, we need to push to different instances, and to do that we need again another component, and this another component might be a load balancer that will be just load balancing the traffic between different instances of our modular monolith. And probably you can already see that it's not that trivial. You need more and more components that will support, for example, scaling of the web application or replicating the databases, or another component for using cache. From two blocks that were on our diagram, we might have now already 30 different blocks, several representations of web application, several representations of our database, cache, load balancer component. This is all quite a lot. Okay, let's say we decided on our infrastructure. Now we need to think about our solution structure, what to do there. And there are several different things to remember. One thing is that we will need to grab our folders and do the representation of these folders with set of projects. And now the set of projects might be different from perspective of the logic that is there, the complexity of it, the type of the module, because we might have a CRUD module, or we might have a module which is responsible for just generating a report, or we might have a module like contracts that is quite complex, and we know that it will grow, so the complexity of the business logic will grow there. Maybe it makes more sense to just split it into several different projects like API, core, application, and infrastructure. But on the other hand, for this CRUD, we might have just two projects, like API project and data access project. Or for report generation, we might have a representation of transaction script where we will just have a script in our API that will generate the report back to the user. So you will have just one project for such a reports module. One more important information. When we started development of our application, we just had one production code project. And inside we had as well some reusable logic that was put into one of the folders. Now we can't do that because we will have a set of different projects for each module, And it would be great that each of this module could reuse the logic that is written in this share logic. What do I mean by share logic is, for example, exception middleware, or it is business rule mechanism handling, or something that is really reusable by most of the projects that you will have inside your solution. This way, you are able to have all this logic in one place and you won't need to repeat it in every single module. At the point where you will think about extracting of a microservice and therefore you will have two deployment units, it would require some package mechanism handling that will grab the logic from shared folders, shared projects, and will extract it into package, and then this package could be referenced by other modules. You can think here about NPM, you can think about Nugget or whatever else you are using on a daily basis in your programming platform. Whenever you start feeling that something is wrong with the approach that you are currently having, so you have a module that is frequently changing and in comparison to other modules which are not that often changed, it's quite painful, or your team starts to complain that it's so hard to merge the changes in the main branch. It might be an indicator that you need to rethink the process that you have, you need to rethink your architecture, and you might need to evolve to another step. Still, you don't need to go hard way. You don't need to just leave everything that you created in first chapter and then focus on microservices because this is the only way to go. No, you can still do that step by step. You can modularize it instead of folders, modularize it based on set of projects. You can scale entire modular monolith to several instances. You can scale database and so on before you even touch microservices world. And this is something that I would like to leave you with, and let me know, how do you approach such evolution in your projects or products? Do you approach it like step by step, or you approach it heavily like, okay, we started with something, now we need entire refactoring and we just throw all the hands on board, all the hands on deck, and we are starting to refactoring it from scratch? Let me know what you think about it in the comments. You can reach me as well on LinkedIn or through my newsletter that I invite you to subscribe. In the newsletter, usually I am talking about things related to software architecture, but things that are not that common, not that well known. Last newsletter was about DORA metrics. If you don't know what it is, just go and read it. The link to the newsletter is in the description of this episode. I would love to invite you as well to the next week live interview that will be on Tuesday, 7 p.m. CET, where we will talk together with Hero, the master of event sourcing, known from Martin and now as well from Emmet, Oskar Dudic, about event sourcing, how to start with it, how to follow, and if there is anything to be afraid of when starting using it. Thanks a lot, have a great day, and see you next week.